Is Thomas Gill, and today I'm going to be talking to you about using electric eels as a source of power. Now, first off, I'm going to talk to you about what exactly are electric eels, how eels actually produce the electricity, the applications for using the electric eels as a source of power, and how electric eels compare to other sources of power. I'm just going to use basically one application because this is a short talk, So, what are electric eels? Despite its name, it's actually a knife fish. More specifically, it's an electric fish, which is a fish that can produce or generate an electric field. Now, the electric eel is the only species in its genus, and it's capable of producing electric shocks of up to 650 volts and 1 ampere. So, it's pretty strong. And electric eels use these shocks for hunting, self-defense, and for communication among other eels. Now, how do these electric eels actually produce the power? Now, it's produced mainly from three organs. Now, I'm sorry, this is in Spanish, but it is from their main organ, which you can see right here, the organo principal right here. The other organs are the organohunter, which is this thin red one, which is also down here, as you could see, and then the sac, which is towards the back of the electric eel. Now, these organs make up 3/4 of its body and allow it to produce low and high voltage electric discharges. And how it does this is it is many electrocytes lined up along each other from the head to the tail. And these electrocytes are lined up in such a way that it allows an ion flow to go through all of these electrocytes. Now, just like explaining it in a little bit more detail, while it's hunting, for example, an electric eel sends a signal from its brain through the nervous system to the electrocytes, allowing sodium to pass through the ion channels, causing a difference in electric potential, which creates an electric current similar to a battery, and that will cause the electric discharge. Now, using the electric eels as used to power a pacemaker, actually. So at Yale, researchers at Yale have created blueprints to create artificial cells that are more powerful and more efficient than the regular cells that they actually mimic. Now, Joanne Zhu, I'm not positive how to pronounce that exactly, at Yale's Department of Chemical Engineering is working on creating an artificial version of the electric eel cell, the cells that, the electrocyte cells. So the um, the electric eel cells are already very efficient and produce enough electricity to power many electrical devices. So the main idea is to take these artificially made cells and place them inside humans to power pacemakers. Now, there's still a little bit of like details that need to be worked out because they're not exactly sure how to make the artificial cells um, create the same sort of sodium ion flow as is seen in the natural occurring cells in the electric eel, but it looks very promising as of right now. And now I'm just going to compare the artificial electric eel cells to current methods of powering pacemakers. Now, the artificial electric eel cells are producing 28% more electricity than normal electric eel cells. And like I said earlier, it could produce up to 650 volts, which is a ton of electricity. They're also 31% more efficient than electric eel cells, which going into the current method is a big deal because the length of time that pacemakers last is based on how hard the battery itself works. Now, if the electric eel cells do not have to work very hard and they're much more efficient, the pacemakers themselves could possibly last a lot longer. Now, with these batteries, the current method, these batteries also have to be replaced, just like regular batteries in your remote or something like that. And these cells could actually be powered similar to bacterial cells and where they could use ATP and just run kind of as long as you provide it with ATP. And then these cells could also be coupled with other electrocyte cells and form tiny biobatteries, which would just be like kind of similar to stacking the electrocytes within the electric eel. And I think that over a long period of time, this could be much better. It could be much more beneficial to those that need pacemakers, and it could possibly be less expensive in the long run if they find an easy way to constantly produce these cells for the needs, um, for the necessary needs. So um, that is what I have to say on electric eels, and thanks.